Hi everyone. In this episode of Keipert Labs, we're going to be talking about predicting ion formation. So looking at some of what we've looked at with the valence electrons in the periodic table as information that we can use to predict how ions are going to form from particular atoms. Okay, so we're going to go through a couple of examples to try and illustrate the point for you to see if that can help with your understanding here. Okay, so the first thing that we're going to do is I'm going to draw a simple atom of sodium. Okay, so we know that sodium is in group 1 and it has 11 electrons to find room for. Okay, so that we can fit 2 in our first shell. We need to fit then 8 in our next shell. 1, 2, 3, 4, 5, 6, 7, 8. And then we need to find room for one more. Because we know that those shells are now at capacity. And so then, let's put 1 there. Okay, so we've got 2, 8, and then 1. Okay, so we can see that we've got 1 valence electron over here. Okay, it's in group 1, so we could predict that there would be 1 valence electron. But what we see is that this sodium atom, so sodium as a metal, is incredibly reactive. As one of the alkali metals, it will explode in contact with water, it will spontaneously combust in air. You know, if you're interested, you can look up YouTube videos of people chucking chunks of sodium metal into the river and things like that. It's certainly worth a look, but to show you that this is a very reactive substance. And what it does is that sodium, as an atom, will very readily form an ion. And what happens is that I mentioned, kind of alluded to this idea that the valence electrons of an atom are the ones that are involved in making bonding or involved when we're getting chemical change. And so what happens is it's this one lonely valence electron over here that is very easily lost for us to form a sodium ion. Okay, so if I'll redraw it over here. Okay, so we've got 2, and then 8, and then 8. Okay, so let's see if I can, I'll use some red ones over here, not to show that the electrons are different, but so you can see both things on the screen at once. Okay, so I hope that doesn't confuse you too much. Any more than usual, anyway. So what we have here, 2, and then 8. Okay, now we recognize that we've lost a negatively charged electron, so that was here, and it has now been lost. It's been taken away by something else. And so we have 2 and then 8. We have 11 protons in the nucleus, but only 10 electrons. So that means that we have 1 more positive charge than we do negative charge. So we have formed a positive ion or a cation, a sodium 1+ ion. So it's got a 1+ charge, okay, on this thing that we've now created after going from here to here. Okay, and so what happens is, so we've had 1 valence electron and we've lost that 1 valence electron to form a sodium ion. Okay, if I take it up a notch and then I say, all right, I'm going to talk about magnesium. Okay, so let's clear that out a little bit. So magnesium, okay, so it's got an atomic number of 12, so it's going to have 2 and 8. And then 2 valence electrons. I know it'll have 2 valence electrons because it's in group 2. And so then what happens is that it will lose 1 and 2 electrons to form an ion. So it will have 2 and then 8. But now it has, and so it looks exactly the same as this over here, except we have 12 protons in the nucleus and 10 electrons around the outside, so we've got 2 extra positive charges, making an Mg2+ ion. So it's lost 2 electrons to become an ion. So it had 2 valence electrons, it's lost 2 electrons to form an ion. Okay, so what we have now, you notice in each of these situations, is that this outer shell, this valence shell now, this highest energy shell here, is full. So we've lost 2 electrons in this case to make a full outer shell of the one inside. Sodium, we lost 1 electron to leave a full outer shell of the one inside. Okay, now let's have a look at an example where we've got something a little simpler. Okay, so where we've got more valence electrons. All right, so I'm going to clean this up a little bit, and we're now going to talk about oxygen. Okay, so oxygen has an atomic number of 8, which means it has 2 and then 6. Okay, so I'm going to take away this one and this one. Okay, so I've got 2 and then 6 to give me an atomic number of 8. Okay, now what we want to do is that for oxygen, it's going to try and seek out the same idea of this full valence shell. But in order to do that, what it's going to have to do is that it's got to go from 6 in its outer shell to 8 in order to do this. So what it has is that it had 6 valence electrons before, and what we've done is we have gained 2 electrons. We haven't formed a magnesium ion. What we have formed, it's an oxygen ion that now has 2 and then 8. It's got 2 extra negative charges than it did before, so it has a 2- charge. Okay, so 6 valence electrons, it gained 2 to give 8 in its outer shell. Okay, now let's look at the next one. Let's look at fluorine. Okay, so fluorine has an atomic number of 9, which means that it's got 2 and then 7. So let's envision it like that. So what happens is it's got 7 valence electrons because it's in group 7, and so it's going to want it's going to seek out this valence shell, this full valence shell of 8. And so the way that it will do that is by taking from 7 up to 8 by gaining 1 electron. So what we did have was fluorine of 2 and 7. We've now got an ion that's made with 2 and then 8. It's got 1 extra negative charge than it did before, so it's now F-. Okay, so we've gained 1 electron to form this ion called fluoride. Okay, so we've gone from 7 valence electrons up to 8. When we had only 6, like in oxygen, we gained 2 to make it up to 8. When we had 1 extra, we lost it to leave 8. When we had 2 extra, we lost 2 to leave 8. So if we looked at something like aluminium, which has 3 extra, have a quick think about what do you think it's going to do? Okay, it's going to lose 1, 2, 3 to leave 8. Okay, so this full outer shell is always the goal. So what it means is that when looking at this, that we see an overriding principle, that atoms will gain or lose up to 3 electrons to achieve a full valence shell. So 3 electrons is our maximum. So we can either gain 1, 2 or 3 or lose 1, 2 or 3 to form an ion. Okay? Okay, so if I just pop our periodic table on here for a moment to help illustrate kind of a key point here. We can look at the periodic table to predict how an atom will form an ion. Okay, so when we looked at group 1, remember, have 1 valence electron. We said that, so like when we looked at sodium, we said that it would lose 1 electron to form a full outer shell. So that means that it forms a +1 ion. We looked at magnesium and it would lose 2 electrons to leave a full outer shell. So ones in group 2 will form a +2 ion. Okay, and so then, when we looked at, say, things like aluminium that would lose 3, that we would form a +3 ion. Now what we said is that we would gain or lose up to 3. Okay, so what we see is the ones in this group, we would have 4 valence electrons, in group 4, that these rules don't really apply, that we don't actually tend to form ions because in terms of energy it's too hard. So what we're going to do is we're going to skip over, we're going to say, alright, looking at group 5 have 5 valence electrons, that they could gain up to 3 electrons to give a full outer shell, so giving a -3 charge. Okay, in this next one that they could gain up to 2 to give a -2 charge. We'd gain 1 to form a 1- charge. Now, that begs the question of what happens to the group at the end. Now, if we said that a full outer shell was what each atom was trying to achieve, and helium, and neon, and argon, and krypton, and xenon all have a full outer shell, the reality is that they do not form ions. Okay, they don't need to. They don't have the same need in terms of valence electrons that the other atoms do. Okay, I'll put an asterisk there to remind us that they're different. Okay, so the noble, this also helps to explain why elements in this group are very, very unreactive, because chemically they don't need to form ions in order to become stable. They don't need to form ions to get a full outer shell, so they don't need to partner up with other atoms in order for this to happen. Okay, in a future video we're going to talk about this idea of ionic bonding, how when we make ions that then atoms can connect together to form different compounds. But hopefully you can see now that we can use the periodic table and the number of valence electrons an atom has to predict what kind of an ion it will form, whether it's positive or negative, and what charge it will have in the end. Alright, thanks very much for watching. Bye for now.